Good evening. In this video, we are going to see the second method of analysis, and we have that method, that is strength concept, or you can say this as C line method, or thirst line method, or couple method, or P line method. So we have different names to this. Now, in this actually, we have already with this strength concept. Now we are in this video, and then third video we are with load balancing. So now in strength concept actually, at any cross section of pre-stress concrete, the combined effect of the pre-stressing force and the externally applied load will result in a distribution of concrete stresses that can be resolved into a single force. Means we are going to calculate the resultant stress at each point, and that resultant stress is due to pre-stress and due to loading, and that stress we can have with a single force. And if we have this locus of these points, and that if we connect that locus of the points, then the line is known as C line. That is compressive stress we are going to say, or pre-stress we are going to say, along this stress line or along this C line. So this is an imaginary line which is connecting the locus of the resultant force, which is developed due to the resultant stresses which are due to pre-stress and loading. Its location depends on the magnitude and direction of moments and stresses due to pre-stressing. Now you can see this. So we have, this will be cable line, and along the cable lattice we have, that is tension in the tendon, which is equal to P. And then we have at a distance E, and we have this force will be developed because we have equilibrium summation fx0 and summation m0, and therefore we should have T is equal to P and C also is equal to P, but we are, these both are along the same line. If we have no load, no dead load, no live load, in that case both are along the same line. But if we have T is equal to P and some loading is on this, due to this loading we have moment M. Then your C force which we have over here is shifted, and that shifting of the C force depends on your magnitude of the force, magnitude of the moment, which is due to external load. So it will be shifted and it will develop a moment which is equal to external moment, and therefore we are going to say shifting that is equal to A. So we have M, which is external moment, which is equal to C into A, equal to P into A, equal to T into A, because we have T equal to P, C equal to P. This is thrust line. And then we have from this A equal to M by P, where A is lever arm between this T line or tendon line and this thrust line, and this is different at different point. We are considering at center, and from this we are in position. So now A we can see. So we have, this will be A, where our C line is shifted, and the moment developed by this C into A or P into A is equal to external moment. And now from this we are going to get that location of this C line at a distance E dash from the centroid, and that E dash we can find that is equal to A minus E. And hence after, if we are going to use this, once I know this E dash, then we are going to get only two stresses. One will be due to pre-stress and second will be due to eccentricity of this C line from the centroid. Means I can say this as C by A and that will be now plus minus C by Z. Now keep in mind, this is above the line, and if you will have above the line, if I will draw this line, and now we have this will be in this position, and if you are going to apply pre-stressing force above the centroidal axis, then we are going to get bending in this fashion, where we have compression at top and we have tension at bottom, and therefore we have plus minus. Then you can write C, you can write P, P by Z, you can write N by A. So different books are given different notation for this. But we have to keep in mind, we have these two terms. One is constant due to concentric pre-stressing force. This is CE dash, I will write better, because we have this will be above the line as E dash. And then we have to solve the problem. So this is little bit less lengthy as compared to stress calculation method. Now we can have this now stress due to pre-stress P by A, P by BD, which will be compression throughout. So we have this will be plus. And now as we have pre-stress C line above the centroidal axis, and therefore we have compression above centroidal axis and tension below centroidal axis. And that you can see this. So we have this will be PE dash. So this is not E, this is E dash. This will be plus, this will be minus, and then we will have this as P by A minus PE by Z. So we can have this actually ZT, and we can have this as ZB. And likewise, we are in position to find the stresses at top and bottom. Now we have considered a problem, and this problem we have solved by both method. First we have solved by C line method, and then we have solved it by stress calculations, and we will have this both answers are same. So now you can have span is given 12 meter, 100 by 400 deep, spanning over 12 meter, that is given. Force is P is 250 kilonewton, E is 75 live load 1.5, and density we have 24 kilonewton per meter cube. Then we have given data, so we have likewise, then we have properties of the section. So this I have considered actually 2.667 into 10 raised to 6. So this we will take it as 2.667 into 10 raised to 6 millimeter cube. Then we have self weight, that will be 0.96 kilonewton per meter, and sorry, we have this as 10 meter, not 12 meter. So this is 10 meter we have. And then we have this as 12 kilonewton per meter, and then this will be 1.5 into 10 divided by 8. So we have 18.75 kilonewton meter. So MD we know now, ML we know, and now we are going to calculate A, we are going to calculate E dash. Now for A, we have M by P. Now M we have to consider as MD plus ML upon P. And then you can have this. So we have this will be cross section. So A equal to M by P, MD plus ML by P. MD we have 12 plus 18.75 by P 250, 0.123 meters, so 123 millimeters. Now E dash we have A minus E, so 123 minus 75, 48 millimeter. Now we have this E dash, you can see we have mentioned over here that E dash we have 48 millimeters. So now we have C over here or P over here. So likewise, so we have compression top, tension bottom, and then we have P by A. P we have 250 into 10 raised to 3, and then 400 into 100, that is 40,000, 6.25 MPa. So you can have this 6.25 MPa. And as we have due to P, we have compression, so plus. And then we have PE dash by Y by I, PE dash by Z, and then we have 250 into 10 raised to 3 into E dash 48 upon 2.667 into 10 raised to 6, 4.5 MPa. So we have 4.5. So we will have above compression both values, below we have tension. So we will have this as 10.75, 1.75. So here we have 6.25 plus 4.5, and below we have 6.25 minus 4.5, and then we will have this value. Now you can see this by stress calculation values, you keep in mind 10.75 and 1.75. So I will write here 10.75 and 1.75, top and bottom. Now we will go for stress calculation method. So we have P by A, this already we have calculated. So again we have plus, that is compression throughout. Then we have PE by Py by I. Now here we do not have P dash PE, and therefore top we have tension, bottom we have compression 7.03. So we have 7.03. So we have here minus, then we have over here plus. Then we have MD, top plus, bottom minus 4.5 and minus 4.5, so plus minus, and then we have ml, which will be again 7.03 mpa. So top we have plus, bottom we have minus, so we have here plus and bottom we have minus. And now you can see this 7.03 which is minus this 7.03. So these diagrams cancels each other. You can see which is PE, and this will be your MD. And then we have again addition 6.25 plus 4.5, 6.25 minus 4.5. And then we will have this value that is equal to 10.75 and 1.75, which already we have seen by your C line method. And so values we are going to get same. So tomorrow we will see that is load balancing, and one problem we will solve, and that is by all these three methods. Then one two problem I can have for unsymmetrical section, so you are in position to understand